Hi everyone, good evening. I believe everyone is doing great. My name is Aman, and here we are going to discuss some of the most important topic of class 11 and class 12. So it will be a continuous series of lectures which are going to come. Uh, so the very important thing, the very first thing that I want to start with is one of the most important chapter in class 11 maths. The chapter is relation and function. Okay. So this is one of the chapter which students find it very difficult at times, more so because it's a conceptual based chapter. So before we go into the relation and function, so the very first thing what we need to understand is that what is the meaning of this chapter and what is the point, right? So as you can see, the name of the chapter itself, relation. So we know what the meaning of the term is, relation, as in we have, we as individuals also have relation. So likewise, the numbers also have relation among themselves. So basically, we need to understand the same thing. As we have relations, same goes for the numbers also, right? So, for example, before we go into the relation, let's first understand one very important thing. Suppose if I say that there is a set A, and in set A, let's say if I say that there are uh, three people whose names are A, B, and C. Okay, and then if I say there is another set where some colors names are given, blue, red, and black. Okay, right. So the very first thing that we're going to discuss about is Cartesian product, because this is something that you'll find again and again coming up. Cart I'm writing Cartesian production. Just give me a second. So yes, so Cartesian product. Okay. So Cartesian product is something that will keep on coming again and again in this chapter. So it's very important that we should understand this very concept to start with, right? So what do you mean by Cartesian product? So Cartesian product is very simple, telling you this, it's written like this, A cross B. And it is just trying to tell you that each and every member of this set A, is related to each and every member of set B. For example, if I'm writing A cross B, all I want to tell you is that A is related to blue, A is related to red, A is related to black. Now same thing goes for B also. B is related to blue, B is related to red, and B is related to black. And if we do the same thing with C, C is related to blue, C is related to red, and C is related to black. Okay. So you can also understand in different way that it is trying to establish all the relation. Like for example, we as human beings are related to everyone in some way or the other, right? We all are humans, so we all are related. So likewise here also, each and every member of the first set is related to each and every member of the second set, right? So we have written all the relations. Okay. Now, so this A cross B brings in all the members, like all the members are related to all the members. But when we talk about relation to be very specific, so what does this relation stands? So there will be some condition. There will be some condition. Okay, for example, if I tell you, that here this A, B, and C are related in such a way that whatever is written in the first set A and whatever is written in the second set B, so these are the initials. For example, the name of the color, like blue, so B is the initial. Okay, so what kind of relation we'll get? If I want to establish a relation that A is related to B in such a way that what we can say, for example, here, if you see letter A, the letter A, there is no color which is starting with the letter A. So that means A cannot establish any relation with all the three colors. But if you see B, this letter B and the color blue. So B is the initial for blue. So this way, B and blue are related. Likewise, you can say B and black is also related. If I go with the same example, same way C, no other color starts with the letter C. So C is also not related to any of them. Okay, so what happens now? So if we try to write the relation here, we can represent the relation in the form of ray diagrams. Okay, now what is this new thing, ray diagram? Nothing new, it's a very simple way of representing. For example, if I tell you, let me make some space here. Okay, and so if I make some space and if I say that there is this set A and there is set B. A had three elements, A, B, and C, and B also had three elements, blue, red, black. Three name of the colors for them. Now, ray diagram, as I was telling you, ray diagram is nothing but a way of signifying the relation. Very simple thing. For example, A is not related to any element of B. A का किसी के साथ भी relation नहीं है, but B का relation is having with blue and B is having relation with black as well. ठीक है? Again, C is not having any relation here. Okay, so here, what is the important thing that we need to focus? Now the new terms which I'm going to write here. So the new thing that we are going to discuss here is that what is the domain, what is the range, and what is the third thing is codomain. Now three terms, very important terms. Let's discuss here. Domain, range, and codomain. Now if you see this ray diagram here, in this ray diagram, which is the element that we are using or from which element we are having connections in the second set. So you can see that only one element is used. That is only B is used. Okay, or another way of writing from here, we can say that whatever the first element that we are using, like B, that is becoming your domain. What is the range? Range is about the second set. That means from B, where connections we are making, where the connections are going. So we are using blue and we are using black. Okay, so we're using blue and black. This becomes the range. Now, what is this thing then? What is codomain then? See, codomain, don't get confused. Codomain will have all the elements in the second set. As simple as that. Codomain will have all the elements in the second set. For example, blue, red, black. So all the three elements will come here. Okay. So this is a very, very general uh, example that we have taken. And one more very important thing that I want to bring your focus to is that if you see here, if you see in this, when I'm writing A related to B, or B, this is how we write it. A R B. That means A is related to B. Okay, so what I'm trying to tell you here is that if you see the elements in this set, in this relation, if you see the elements B comma blue and B comma black, so you are going to find these two elements in this Cartesian products also. For example, B comma blue is here, it's present here, and B comma black is also present here. So B comma blue, B comma black, both are present. What do we mean by this? So if you have little understanding of chapter set, you'll be able to say that whatever relation we are writing here, this is going to be a subset. Okay, this is going to be a subset of A cross B. Okay, this is going to be a subset of A cross B. Now it may happen that all the elements are related to all the elements, right? So for example, then it may happen that it can become it's just a subset. Okay, it may happen that it's a proper subset also. All right, so this is a basic definition. This is a basic definition. The important thing that we need to remember is A related to B. So this relation, the point is the relation is a subset of the Cartesian product A cross B. So this is a subset of A cross B. Okay, let's very quickly see a very simple example. For example, if there is a set A, 1, 2, 3, 4, 5, and if uh, I have taken a set B such that we have, let's say, 4, 9, 16, and 25. Okay. So if I use the Cartesian product, and what is the relation written here? So relation is that, okay, A comma B. So A is related to B in such a way that this first element such that, this is the condition written here, that A is, or you can write in a different way also, this B is a square of A. Okay, B is a square of A. If you're getting confused, you can make it X and you can make it Y, and you can say that, because this is what we normally use in our day-to-day math questions, that X comma Y such that Y is a square of X. This is the relation. Okay, where you can see that Y belongs to B, X belongs to A. Okay, now let's try to write the relation here, and it's very simple. You can say that A is related to B, and the numbers will be, the relations will be, as you can see, 2 and 4, they are related because 4 is the square of 2, so 2 comma 4. Okay, 9 is the square of 3, 4 is the square of 16. 5 is the square of 1. If they ask you to represent it with a ray diagram, write A here, write B here, okay, and we write the numbers. In A we have 1, 2, 3, 4, 5, and in this we have 4, 9, 16, and 25. So 1 is not related to anything, but 2 is related to 4, 3 is related to 9, 4 is related to 16, 5 is related to 25. Now very quickly, if we want to write down the domain of this, so domain is nothing but all the numbers or all the elements that we are using from the first set, which is 2, 3, 4, 5. What is the range? All the elements which we are using from B. So we have a relation of 4, 9, 16, and 25. All are being used. And what is the codomain? So you see a very interesting thing here in this question. The range and the codomain are going to be the same. This is also going to be 4, 9, 16, and 25. So it can happen, right? Range and codomain both are same. That is going to happen in some of the cases, not an issue. Okay. So there are more important things in relation. It's a bit of complicated and a logical chapter. So a lot of details are there, which we'll discuss, but maybe in the coming class, right? So hopefully we'll meet again and we'll discuss it further. Thank you, everyone.